Cool, folks. Thanks for being here. Thanks, Sam, for inviting us. It's always a pleasure to talk about something that you actually love, like platform engineering and DevOps. I've been working with that for a while now, and Tiago the same. I'm Lucas Duarte, a principal specialist SA, focused on containers ISV here in AWS, based in Austin, Texas. I'm gonna hand over to Tiago so he can introduce himself.
Sure. Guess what? I have the same role and work at the same company as Lucas.
The same
I'm
for the
just
reason we
getting
are friends.
also. Yes, working also with containers for startups here in Latin America.
Great. And in today's presentation, we are gonna cover we're gonna cover repo tricks for scaling GitOps across Kubernetes. But we're gonna before talking about organization repositories and everything, it's important for us to define some concepts and give you some context that we are gonna be using throughout the presentation. So first things first, everything starts when you provision your cluster, right? So when we are talking about provisioning, everything starts when we provision our cluster. You choose an orchestrator. In this case, we're talking about Kubernetes. So it's not just about the orchestrator. We need to pick a compute where we're going to deploy our workloads. In this case, could be Carpenter, managed node groups, whatever you are using to host your worker nodes. And then on top of that, you need cluster add-ons because no Kubernetes cluster works without some cool add-ons. You need those add-ons to do from networking configuration all the way to storage configuration, core DNS, and then your additional add-ons like Prometheus and everything. But with all of those add-ons and all of that provisioning, depending on how you are provisioning, it will come day two operations for sure. And then when we are talking about where those components land, it's important for us to explain in the context of this presentation what we mean by foundation infrastructure, right? So in this case, you saw that we have Kubernetes, we have maybe a RDS database, DynamoDB tables, any foundation component. And then we wrap this up, and then this is what we call foundation infrastructure. And because on top of the foundation infrastructure, you could be wondering, but what are the other categorizations of infrastructure that we have? Some applications, all of them most likely will need an IAM role. So you can map to pod identity or IAM roles for service account or whatever add-on you are using to map those credentials. Then some queues. Those apps will need some queues as well. App 1 and App 2 will need S3 buckets. And then a DynamoDB table for App 3. All of those infrastructure resources, for the context of this presentation, is what we are calling application-related infrastructure, right? And then on top of the foundation infrastructure and consuming the application infrastructure, we are actually going to deploy the workloads. And when we are talking about all of that infrastructure and those components, usually there is a specific team that is responsible to manage those components. So the infra slash ops team, and again, if you don't use infra, could be SRE, DevOps, infra ops, DevSecOps, DevFinOps. I mean, there's a lot of terms and companies nowadays use that interchangeably. It's hard to say some words when our Portuguese native speaker interchangeably. So companies use those terms interchangeably. And then essentially what I'm trying to say here is that there's a specific team or a group of people that is responsible to provision and maintain those infrastructure related resources in your environment. But it's also important to talk about the operational model evolution because those two teams, the application development teams and infrastructure and operations team, they have different responsibilities. As you saw, the infrastructure and operations team, SRE, DevOps, DevSecOps, ClickOps, whatever you want to call that team, they are responsible for the infrastructure layer, usually both for foundation and application related infrastructure. And then the application development team are responsible for the application logic. And maybe they are able to define some YAML files on their repository guided by the infrastructure and operations team. So we know that this is the operational model that we have right now. When we have a single team sending a request to our infrastructure and operations team or DevOps team, they will deploy the updates, create the infrastructure, change the infrastructure layer, and then the application development team can be happy and deploy their workloads on top of the cluster. That's great. But what happens when another team comes in, and another one comes in, and another one comes in, and another one comes in? Have you folks seen yourself in that situation? I'm gonna ask here because I'm seeing the chat, so feel free to send any comments that you might have. But this is what usually happens if we don't have a good way to empower our development team with something that they can actually consume. Because One thing is using infrastructure as a code. Another thing is make that infrastructure as a code and GitOps artifact consumable. And then at the end of the day, sometimes ops are villains, and that's the perception that we get. So how do we overcome that challenge, Tiago? What is a good way to overcome that challenge?
Why don't we just shift left and give the responsibility and the autonomy to the developers so we can have the developers running the code base, CI/CD pipelines, monitoring, security, infrastructure as a code, everything that is required. But you might be asking yourself right now, and the cognitive loads on the developers. Now they are doing everything. And what is the DevOps, infra, DevSecOps, whatever team that Lucas mentioned about doing right now? So, and another challenge that might appear is every team could be doing this in a different way. So one team using, for example, CloudWatch for monitoring, another team using Grafana, another team using kubectl logs or console log, and you don't have a standardization. And that can be a challenge as your company grows and you have multiple teams working on that company and multiple also microservices being built, for example, and one team per microservice. So
I really like team number three, Tiago. The security that they define there is really nice.
Yeah, it's kind of different. Yeah, that's new to me as well.
Yeah.
What is security? Yeah, so that's something important. So how can we make sure that every team will have security built into their applications? One way to go is having the platform team defining those best practices. So they create the patterns on how to deploy both the applications on Kubernetes, so Kubernetes objects at the end, but also the infrastructure related to those applications, such as queues, databases, and so on. And that's all already pre-built with the security and governance that your company mandates. So you make sure that the developers right now, they still have the autonomy to create infrastructure for the applications, but now they are following those best practices with security and governance pre-built into it. And we make sure that everyone is using the same stack for provisioning similar applications. So let's consider, for example, a Kubernetes application. We might have different objects here. We can have a HPA for scaling the application, a deployment, for example, to define how to deploy it, ingress and service to expose that application, config map with configurations. We usually need multiple of those objects to define a single application. And when there is another team deploying another microservice, they create the same set of objects just with a different configuration for each of them, with a different container image, with a different scaling policy, and so on. And another team, the same. You might be thinking, this is fine. We can just copy and paste the configuration from one team to the other. But what happens when there is a cluster upgrade? And let's say you have a deprecated API version, and you have to change that in your ingress, for example, to a newer version and adapt for the newer API version. Will you do that in all the files in all the applications and do the change one by one? Or what else could we do here to improve this? We could, for example, package the application. And there are a few different ways to do the packaging. You could use Kustomize, you could use Helm. In our case here, we choose Helm because we know a lot of people already know about Helm. And the idea is that you package all those objects that define your application. Let's take an example here just to be more practical, and that will help in the future during the presentation as well. Let's say a three-tier application. It will have a front-end, back-end, and a database. For now, let's just consider the part of the application that is running on Kubernetes. So front-end and back-end could be running there as a container, for example. You could have a Helm chart that defines that front-end and back-end, how it's exposed, how it scales, the HPA, and so on. And then the application development team just consumes that Helm chart, creating a Helm release, specifying their container images for those microservices, and also how they want to scale, for example, the application. So they can customize to their needs. But all the teams here will be using the same Helm chart, just specifying for their needs. And when there is a change that has to happen to that Helm chart, the deprecated API version, as we just talked about, the team can just go here, the platform team can just go here and create a new Helm release or a new Helm chart with a new version that has these changes. And the developer teams, they can just change their Helm release to this new version when they are ready to do so. But we have a way to do this in a standardized way, and a way that the developers don't have to worry about what has to be changed to be able to use the newer version. But Lucas, you mentioned about infrastructure related to the applications. How can we manage those pieces in our architecture?
Right. Applications, as we saw in the beginning, will often require infrastructure, and it's important to us to see the infrastructure as a code landscape overall. So when we are talking about infrastructure as a code landscape, we have different tools and capabilities. We have declarative tools using HCL, JSON, and YAML definitions like Terraform or CloudFormation, and then we have code definitions like Pulumi and CDK. But there's one thing that I want to bring it back is doesn't matter which tool you are using. What matters the most is how you organize that tool and then make that tool consumable to your developers. So let's take a look to what we have today in the scenario that we're talking about. So we have the application development team and infrastructure and operations team, DevOps and SRE team. They will send a request and then, hey, I need the infrastructure related to my catalog, to my checkout application. What the infrastructure operations team will do, they will create what I love to call the sausage Terraform because it's a Terraform with 750 lines and it's very non-maintainable. And then this with AI nowadays can make that Terraform code really, really big and very, very non-maintainable. But you know what? We have created this for the developers. We don't have a lot of time to think about a better structure. So the next developer that will come in, we're just gonna copy and then paste the checkout definition to a new definition. We're just gonna change the variables now. So we're copying the checkout. Now that's the time that Tiago needs to pay attention when I give him the hook to bring the next animation in. You see? You see?
Sorry about
Awesome.
that. I clicked in another window.
Thanks, Tiago.
Was
Thank
like
you,
live.
thank you. So you paste the catalog applications and then you are using the same resources, right? You're using S3, IAM, and DynamoDB, but they have different variables, maybe different configurations of IOPS here and there. But you need the same, exactly same infrastructure, but with some different configurations. Have an idea. Let's do the same thing. Let's copy and paste that. But using the same problem that we saw with Kubernetes upgrades, imagine that now we need to enforce an S3 bucket policy or something across all the infrastructure related resources. How we would do that? I already know. Let's go to each single file or each
Use
single
Gen
folder
AI.
or use GenAI to change everything, right? There's no better way to do that. This is where we need to talk about infrastructure, composition, and modularization. All right, so a way to overcome that challenge would be now we have the Terraform resources in the same way that Tiago showed us the YAML files. Now we have the Terraform resources, in this case, Amazon S3, IAM, and DynamoDB. We can do one level of composition using, in this case, we're using Terraform as an example. So that would be your Terraform models. So now we are creating an abstraction on top of S3, IAM, and DynamoDB. And then we are calling that S3 least privilege and DynamoDB least privilege. But remember that all of our three previous apps require the same set of infrastructure resources, but just with different configurations. So we can go one level further and then create an aggregated module who is essentially a module of modules in Terraform. This is just an example of one composition of infrastructure resources that we could do. We are doing that with Terraform. We can do something similar with Crossplane. We can do something similar with CDK. In this case, we're using Terraform as an example. So now the entire flow would look something like this. The infrastructure and operations team will create and maintain those modules, and of course they can receive requests for new modules as well, or unblock the development team to contribute to the modularized definition, because now we have a modularized definition. It's much easier to someone come to me and contribute back to my IC modules catalog. And then the application development team will essentially consume and then populate that in a repository or whatever they are using to provision that infrastructure. And I saw a comment here in chat, and I just want to bring that up because I think it's important that someone said, now you have to build an IDP so app teams can do it by themselves. That's right, but IDP is not just a cool UI, right? It's how you build those abstraction layers, how we organize that stuff to be able to scale. And then once we have the processors all defined, then we can put a UI on top and empower the developers. But if you have something like this and teach the developers how to populate YAML files into a Git repository following a pattern, that could be an option as well that doesn't involve UI, for example. But in this case, now the developers are consuming, going back to the presentation, now the application developers are consuming the modules and then defining those modules somewhere. But there's a problem that Tiago just gave you a spoiler. We need probably a pipeline hooked to that repository to be able to provision those infrastructure resources. And that can be a challenge.
Yes, Lucas. And let's see why this could be a challenge. Let's say, for example, you are using Terraform, CloudFormation, or Pulumi, for example. What will happen is you have to deploy that infrastructure. So a way to do this is having a two-step apply. So what is that? You apply the infrastructure, you create the required infrastructure for the application, you store the state somewhere so that you can do updates later on to the changes that you have deployed. But what's important here is you need probably some outputs of this infrastructure to deploy your application. So let's say, for example, you are creating a DynamoDB table or an IAM role. You probably will need the name of that DynamoDB table. You will need the name of that IAM role or the ARN resource of that resource that you are creating for your application to be able to use that later, to reference that database or that table, for example, later. So you have to pass those outputs from your infrastructure into a repository that has a definition of your application, so that later you can deploy this using GitOps, using CI/CD, whatever you want to use to deploy into Kubernetes. But it's important that you have this right now separated into two steps. One is deploy infrastructure, then you get those outputs. It can be automated or manually and pass this into your application to be able to deploy. We could do this differently, right? We could use, for example, controllers. Nowadays, we have controllers for Kubernetes that allows you to deploy infrastructure. Let's take ACK and Crossplane as an example. You could define ACK and Crossplane that extend the Kubernetes API in a way that you have new custom resource definitions, and you can create new custom resource that define infrastructure. So, well, I said a lot of buzzwords here. Let's define how this would look like in a practical example. Let's say you want to create an S3 bucket. What you do is you create an object inside of your Kubernetes cluster of the kind bucket, and you have all the specification on how that bucket should look like. And the controller, in this case, Crossplane or ACK, would look into that object, see that new object being created, and then create that bucket inside of your AWS account for you and manage those configuration when you change the configuration on that object inside of your Kubernetes cluster. But for today's session, we won't focus on Crossplane and ACK. The same concepts will apply as you will see during the presentation. But for today's session, we will focus on the Tofu controller because we know a lot of companies already have Terraform cold build. So we wanted to bring an option that you can reuse the Terraform that you already have and apply that from within your cluster. So Tofu controller is similar to these other ones. It's a controller that extends the Kubernetes API. It allows you to create new type of objects, new custom resources. But there is a difference on the Tofu controller comparing to Crossplane and ACK. The Tofu controller won't have all the definition of all the infrastructure pieces inside of your Kubernetes cluster, inside of your etcd of your Kubernetes cluster. With the Tofu controller, all you have is a Terraform object, and that Terraform object will point to your Terraform module that Lucas just showed to us. So you might have a Terraform module in a GitHub repository, and you are just pointing to that Terraform module, passing the variables to deploy the Terraform module. So the definition of the Terraform module itself is not inside of Kubernetes, just a pointer to that Terraform module. And for Crossplane and ACK, you would have everything inside of your etcd, inside of your Kubernetes cluster that you can take a look. But what is the benefit of using a controller like this? The idea now is that you can define your infrastructure as a Kubernetes object. And since it's a Kubernetes object, you can also package it using a Helm chart. So now we can take the three-tier application that I mentioned to you earlier and now have both the application front-end, back-end, and even use, for example, an S3 for front-end if you want so, and using a database for your storage of your data as well, and have that all being provisioned within a single package that is our Helm chart. And now our developers can use this Helm chart, deploy the application for their needs, customize to their needs, so which container image to use, how to scale, which database to use, or how to create a database, customize to their needs, but using the same standardized way to deploy the infrastructure. But you might be thinking as well about dependencies. Let's say I want to create an EKS cluster, but for me to be able to create an EKS cluster, I need a VPC. You could, of course, manage the infrastructure pieces inside of Terraform itself with the dependencies, but let's say you have a dependency between application and infrastructure. For example, let's say you need an application to be deployed, but it needs an a role for service account before it can be deployed. So how can you manage those dependencies? Using Helm, it's possible using multiple Helm charts, but Crow makes this a little bit easier since you can just, for example, use the outputs of one resource as an input for another resource. So let's say I want to create a deployment, and that deployment needs an output from my AAM role or from my AAM role for service account output to be able to be created. And since you are using that output as input in another resource, the Kubernetes, the Kube Resource Orchestrator or CRO will already create that dependency map and create those resources as required as you are defining those dependencies. So you don't have to worry about which will be created first or to have any race conditions as they are being created. But Lucas, as our company grows, probably we'll have to manage multiple environments, right?
That's right. Let's just copy and paste all the pipelines for every single cluster and single application that we have in our company, and then we can divide that times by the amount of microservices that we have. So we are looking for around 755 different pipelines, Tiago, just to
Sounds
deploy.
great. And what
What do you
when
think?
we have a cluster upgrade? I don't have that same image again, but it
You,
works
you
here.
just you just use GenAI to do that. Yeah,
Okay,
that's
let's
the
do that. Let's see if it works.
right. So the problem that we have now, folks, is essentially we might have different clusters that might look the same, but with different configurations. But we also might have different production clusters. So we could have an active kind of fashion here. And then in our production clusters, we would have something like this. Since it's active, I want them to be mirrored. So I want them to be the same. So I want to have the same add-ons, the same applications installed. So how can we make sure that we distribute those configurations that we just talked about right now across multiple clusters, right? By this time, you probably know that the next thing that I'm going to talk about is
It's not
essentially,
GenAI.
it's not GenAI, it's GitOps this time. This time it's GitOps. So I'm assuming that most of people here that are watching this presentation know what GitOps is and what it's used for. But just to level set, I'm gonna explain a very fast way so we can go to the main part of the presentation, the organization of the repositories and how we organize the controllers. So GitOps is a way that your Git repository will become your single source of truth. So essentially, whatever you have declared in your Git repository is what we're gonna have be installed, is what gonna be installed in your cluster. And then if you delete something to your cluster, then we have a mechanism that will say, hey, I think there's a difference in configuration here. So let me reconcile that back, creating what we call a immutability firewall. So we have Git as a centralized single source of truth, and we know that whatever we declare there is what we're going to be running in the cluster. So it's important just to make sure that we give a high-level overview what GitOps is, because it's not a way to create your Git patterns. You are not using GitOps if you are using GitHub Actions, for example. It's a way to reconcile those objects, and it's a very similar way that the controllers in Kubernetes works, right? So we have a deployment controller. Deployment controller will make sure that the amount of replicas that you have defined there are actually running, so in number of pods. And then if you go there and delete a pod, deployment controller will make sure that it comes back up and make sure that it's a state is what you have declared on etcd. In this case, we're doing the same thing with Git and some additional controllers. I'm gonna hand over to Tiago, but I have a question right now. Is Flux Tofu controller developed natively for Flux only? How to use it in Argo CD? Yes, Tofu controller is developed for Flux because it uses Git repository definition, which is essentially a definition of Flux. But I've seen people using Tofu controller plus Flux just for the infrastructure resources to be able to provision and reuse the Terraform code base and then use Argo for the rest of the stack. So that's a pattern that I've seen customers using. But Tofu controller in this case is available for Flux. But awesome. We're talking about a little bit about GitOps and everything, but what are some topology and patterns? Because we understood that we have just a single source of truth. How can we build those controllers and organize our controllers in a way that we can scale and it benefits our company, right? How can we do that, Tiago?
Sure, Lucas. So we could just have a single Git repository, for example, here, and I won't cover folder structure for now because Lucas will cover this in details later on. But we could have a single Git repository and have, for example, a cluster, a Kubernetes cluster, in this case, for example, EKS, for each, let's say, business unit or for each application. It depends on your use case, your business use case on how you will structure this Kubernetes cluster. You might need to have, for example, Kubernetes clusters on premises for some requirements as well. So you might have multiple Kubernetes clusters and each business units, let's take that as an example for now, will manage each of those Kubernetes cluster. You could have Argo or Flux or any GitOps tool of your choice installed on these Kubernetes clusters and each business unit managing that Argo CD pointing to a single Git repo. But if you want to have a single point of view, a single Argo CD UI on which you can manage multiple clusters, you could have something like this as well. Have a control plane EKS cluster, a Kubernetes cluster with a GitOps tool installed as well, for example, Argo CD, and that Argo CD pushing changes to all your data plane clusters where you have the application itself running. But what happens if, for example, that cluster goes down or if that Argo CD stops to work? You won't be able to push changes to any of your environments. So you are introducing a single point of failure here. So maybe that's not what you want to do as well. What else could you do? You could, for example, also have a strategy mixing both. You could have, for example, a control plane cluster that your platform team is responsible for, and only the platform team will have access to that Argo CD. And you have like roles and responsibilities here in which the platform team will be responsible for deploying the add-ons that are required as part of your base infrastructure for your applications into all of those clusters and manage the updates to those add-ons, but still having a Git repo for each of the business units on which that business unit is responsible for that Git repo, maintaining the Git repo, but also having an Argo CD that will run in each of those clusters for deploying the applications so that if that central account stops to work, you are still able to deploy changes. But there is also another approach that you could use here as well. If you don't want to have an Argo CD itself running on all of those accounts, you could also use the Argo agent. It's a way for you to run like on those data plane clusters, just an agent of Argo. Let's take as an example Argo here right now, and have a central account or control plane account with Argo CD installed. And those Argo agents will work in a pool-based fashion on which they will get the changes that are defined in that control plane Argo and deploy that in those data plane clusters that have your application for your business units running. So there are a few different ways to do this, and each one will have pros and cons. But now that we saw a little bit about how to structure the cluster, I think it's even more important to see how we can structure actually the Git repositories to fit into those use cases. So Lucas, why don't you cover that for us?
Awesome. Thanks, Tiago. Yeah, I mean, we have multiple ways of deploying Flux and Argo, but depending on how we organize our repositories, a lot of that organization of how we deploy the controllers can change as well. So let's take the first example that Tiago said. Let's imagine that we have a standalone controller installation into every single cluster, and then we have a single Git repository that could be using different branches or even the same branch. What is the main problem that we see here? One, we are copying and pasting add-ons. So if we need to update add-ons in dev and then roll out that across all the environments, we need to do that across essentially, even if we want to change a version, we need to do that in every single manifest. And on top of that, we have the application definitions. But the most pain point that we see when we're using a strategy like that for different environments is essentially role-based access control. You don't have a good way on Git to define folder structures and who accesses what in that folder structure. So essentially what will happen here is it's going to be really hard to do that. So that leads me, even if you're using different branches, it's going to be really confusing with your PRs coming up to different branches, and then you cannot merge back to the main branch or using different branches of structure. So honestly, this is really hard to do. Another way that we could do it is essentially we could create a separate Git repo per cluster, and then in each Git repo, we are using the main branch, so we are following Git flow to contribute back to the main branch, but we have different repositories for each cluster here in each environment. So in this case, we have dev, QA, and prod GitOps repositories, each one of them with their own application definitions and add-on definitions. But sooner or later, we're going to notice that we are replicating add-ons configurations because we want to have a standardized version of add-ons across all the clusters that we want to avoid EKS, to avoid Kubernetes upgrades. So sooner or later, you're going to see that you can find yourself in this situation because we're copying and pasting again, and again, and then that can lead to cluster upgrades. So what is another way that we can overcome the challenge of standardizing whatever we can and then still giving the flexibility to developers or whoever is interacting with this repository a way to do that at scale? So we can have a centralized Git repository where we have just templates of definitions, and then essentially into each cluster that we have, we can define references to those definitions in the main repository with different Git sources. And then if we do that, we are able to control the version rollout of those add-ons in a single place. But at the same time, since we are defining just a reference, we can replace or put whatever we want into specific configurations. So this is a more friendly way to overcome that challenge. And if we are talking about Flux, I know that Tiago talked about Argo. As of now, we can do that with apps of apps pattern in Argo. But in Flux, you can do that using Kustomize and post and variable substitute, where essentially you can have just a single repository where you have just the add-ons, and then you have the specific variables for each cluster, either in a config map or in a secret. And then Flux can get those variables, interpolate them, and make sure that for the dev cluster, you are using the right IAM permissions. They're going to be different than the QA cluster, but the definition of how to install is going to be the same, right? So ever since the beginning of our presentation, I think the most important thing for us is standardize what can be standardized and can be reused across multiple places. So now, bringing everything together that we discussed, I would like Tiago to talk to us how we can bring everything together, including the different Git topologies that we discussed.
Sure. So let's consider we have our Git repository for the add-ons and the application that Lucas just mentioned about, and also an EKS cluster with our GitOps controller of choice. Now, remember that we have the infrastructure, so we define that as a module, and that module is now also in a Git repository. And then we have our Helm chart definition that we have stored in an OCI repository, let's say ECR, for example, on AWS. And we have that Helm chart stored there, and that Helm chart definition points to our Terraform module so that we are packaging both application and infrastructure together. Now our developers, when they want to develop and deploy a microservice, let's say the product microservice, they still have the CI pipeline in which they have the test for the application and also build at the end a container image. But when they are going to deploy, they just create a Helm release inside of their application Git repository, pointing to that Helm chart, specifying which are the container images they want to use, what are the requests and limits for the application, for example, and also what are the infrastructure modules that they need for that application. The same for other microservices. So they just reuse the same Helm chart for that same type of architecture. So if it's always 3-tier applications, you will always use the same blueprint in that same case that we just mentioned at the beginning of the presentation. But you might have different Helm charts for different use cases as well. But what about add-ons? We could just have that centralized repository for add-ons that Lucas mentioned to us, where we have the definitions on how those add-ons should be deployed. We have all the versioning of those add-ons. And what we could have here is just a reference. Let's point to that Git repository, reuse those add-ons in that specific version that I want to use in this cluster right now for that business unit, for example. And then our GitOps controller will see those files or those Helm releases being created in our Git repository and reconcile this, creating and deploying both the infrastructure and the applications inside of our AWS account on Kubernetes cluster. But what if I want to have more dedicated, like more separated responsibilities between the platform and the developers or the business unit developers? We could have, for example, the Git repo for the for the platform team that has the add-ons that we just saw about, and have that strategy that we talked about as well, about having a control plane cluster with your GitOps controller that the platform engineering team is responsible for. They will have all the definitions there that are required for setup the base of your Kubernetes cluster and that their applications can be deployed later into. And that's something that they manage, and they can push those add-ons into the data plane clusters or the clusters that have the application itself, having those separate responsibilities. And the application teams, the developers, still will be using their Git repo to define the application and the infrastructure related to the application. So if you found this interesting, this session today, we would like to invite you to take a look into this workshop. You can do it self-paced, or if you want to run it with us, just get in contact with the account team. If you work with AWS, with the account team from AWS that works with you, we can do this together as well. But all the content is publicly available, even like the infrastructure, the Terraform modules and everything that we created. So if you want to run by your own, you are able to do so as well. And this architecture, it's focused on SaaS, so multi-tenant applications, how to define tiers, how you can do tenant onboarding, how you can, for example, apply updates across all of those tenants. And it's using this technology stack that we covered during the presentation today. So in this case, we are using a Tofu controller for applying infrastructure changes and Helm chart to package the application together. I would like to thank you all for the participation. This QR code is really important to us. It's a survey on what did you like or what did you not like during this session. So feel free to leave 1 star if you did not like. The only thing I ask you is, if you leave 1 star, just leave also a comment on what we can improve so that we know how we can improve further and always deliver better presentations. And just a quick comment I would like to leave before I give lead it to you, Lucas, is we had some jokes about generative AI or Gen AI during the presentation, and just my comment on this is, Gen AI helps me a lot during the daily basis.
We use every day.
Develop and use and improve architectures, and also like doing developing to build demos and so on. But Gen AI, it's not deterministic, so it won't solve all the problems. So some of the concepts, or most of the concepts that we covered here today, are still important. You will still have to define your platform engineering, because Gen AI will not solve everything. So let's use the tools as they are exposed to be used. So Gen AI for helping you in productivity, and platforms for the use cases that we discussed here today. And Lucas, yes?
And if you have a mature enough platform, if you have all those definitions in place, an agentic workload could just act as a glue to whatever you have, because the patterns are already there, right? So this is it. You're not creating anything. We're just orchestrating what you already have. I just want to say that here's our LinkedIn page. If you want to run the GitOps workshop that we show it to you in previous slide, but you don't have an account manager that you talk to, feel free to follow us on LinkedIn, because we're going to be posting whenever we do an event for that workshop, and it's going to be probably before end of the year. So if you want to execute that, follow us on LinkedIn, and then you can get that invitation as well. Now we can take some questions, I think. I see a question here on chat.
Yeah, we
have a few minutes left. Yes,
we definitely we can stay a little bit longer as well. It's fine.
Awesome. And there's another interesting topic that we could cover that Lucas just briefly mentioned about. That is AI for platform engineering, but that's for another session.
This is a very interesting topic. So we just published the state of AI and platform engineering, and it came out around the same time as the Dora report, the latest Dora report. And they conveniently said the exact same thing, which was basically, good AI. The very few who are really succeeding with AI is because they have a good platform. I think that when we know that famous kind of MIT number, 95% of enterprises are failing with AI, that last 5% are the ones who are really using platform engineering for it. So I'd love to maybe do another webinar with you guys and touch on that AI topic. In fact, today I'll literally be talking about AI and IAC, and that exact topic of deterministic versus non-deterministic in a meetup in New York. So if anyone's in New York in like 2 hours, you could come get some free beer with me and chat about that. But for now, let's do some questions. So we'll stay for a few minutes over if you guys don't mind that. I'm happy to stay. Virtual beer. Well, if you no virtual
You
beer.
can imagine that you are
Yes.
drinking a beer
You
here
can
with
you
us.
can drink a beer in about 2 hours, and then I'll also be drinking a beer, and we can enjoy it together. Um, so, are there any questions? I think you guys did a pretty good job of covering questions as you went. I think Ivan's hasn't been answered yet, so I'll
Yeah.
start with Ivan Penchev. So, thank you, Ivan. Day two operation question. How do you reconcile errors inside Tofu controller? Common example is state locks.
Yeah, so I think it depends on what you are doing, but essentially Tofu controller, if I'm not mistaken, already has a mechanism to work with state lock. But even if you're not using state lock on Tofu controller, you could use a DynamoDB table for your state lock and embed that on your Terraform module that you are using or whatever is the interface, and then the lock would be on Dynamo, would not be locally. So the other execution would check the Dynamo to see if the lock is still there or not, if you can proceed with the execution. So I mean, there's different ways, but usually the way that we fix that on Terraform, it's using external storage like DynamoDB table to save the logs, and that can prevent you to those log challenges and different logs in different places running locally. So I think that's it.
And even if you are using the secrets from Kubernetes that is the default of Tofu controller for your state, we highly recommend you to also backup that because you probably don't want to have your state just on etcd. And like having DynamoDB and S3, as Lucas mentioned, would already help with that, even if you're
Yeah.
applying from two different places as well on that same state.
Yeah, and I mean, storage like S3 is cheap. The way the Tofu controller works, you can persist that state in a config map and in a secret. And Tofu controller already has its mechanisms to lock and then don't allow multiple executions to the same state. But you could also use an external storage, like we said. One thing that I want to bring up, Sam, that you're talking about is uh, you mentioned that if we have an organized platform, it's easier for us to add AI on top of that. And I 100% agree with that. I just want to highlight that when we say platform, it's not just backstage or a front end, you know, because I think it's important to highlight that because
Wait, a platform isn't just a UI?
Is
you
it
see
not just a
exactly.
developer portal?
No,
Yeah, I
it
thought I
is.
thought it was
It
just a
is.
UI. Isn't that what we're talking about here?
Exactly. So I just want to bring this up because I mean, you folks here on that were watching the session saw that we didn't even mention UI, but everything that we covered is platform engineering and building platforms. You know, for us to get that last stage of hub and spoke plus Helm charts plus infrastructure and composition, if we get a stage like that, everything working, everything being processed, it's very easy for us to put something on top that will act like a web. And for AI, since everything is based on context, the more capabilities and interactions that we have, more context we can give to AI, and then better can plug and play in our platform. So one thing, and that could be for another webinar for sure, Sam. But just to give folks a little bit of expectation, so they would join the next webinar that we do, is you don't need to have a full-blown platform to start to apply AI and agentic use cases to overcome specific challenges, right? So you don't need to just have a backstage where you plug AI and have everything and then you have that broad view. You can plug those agentic workflows into maybe a CI pipeline or maybe into
Specific
a
use case.
validation of something, or maybe you want to apply a network policy when something happens and you detect that by Falco. It's you can still apply AI there, not on a full-blown platform. Of course, as I said, if we have that context and that web in place, it's easier for the model to follow the context and don't hallucinate. But this is maybe a topic for another discussion.
Yeah, and I mean, this is great. I know people questions are coming in, but I'm gonna use this moment to say one other thing to really zoom in on something that Lucas said, and we will do another webinar on this, I promise. There's a lot to say. I think all of those specific examples that Lucas gave, if you are thinking about using AI and things, it's really important to make sure you're actually doing it for a specific reason and you have a clear goal and a clear use case. I know that's not the topic at hand right now, But you're probably super hyped after this, and you're like, wow, they told me to go get AIifying. The ones who succeed are because I'm going to try and they say, I want to do X, and then they do X. They don't say, I want to use AI, and then just go try and figure out AI wise. So I wanted to close off with that point on that. And then let's do a couple questions that are on the
Yeah,
topic. You guys get
yeah,
me too excited about this
yeah.
AI stuff. Don't get me going. So next question from Matthew. Are there any examples info of these tofu controllers and Helm files and how that works?
Yeah, if you scan the QR code that Tiago had on the screen, if you want to put that back or send here in chat, the
I will
link,
send the
Tiago.
link to the workshop on chat.
Yeah, so there we as Sam said, it's very important to define a use case. So even to demonstrate platform engineering capabilities, if you don't have a good use case, it's very hard to demonstrate something. So for that reason, we define it SaaS as a use case where we have meaning to build different Helm charts, for example. So you can use that to inspire yourself. Tiago, I don't know if Tiago sent to everybody, but if not, I will
Now,
ask Sam. No, yeah.
yes.
No, yes. Awesome. So there is still no easy way to populate variables from TF to GitOps way. So that's the point. If you are doing a two-step apply, there's no easy way. If you are using something like an internal controller, like Tiago mentioned, there's easier ways. It's not gonna become like super easy, but there are easier ways. So in Tofu controller, for example, Tofu, the custom resource, you can specify to give the output if they are not sensitive to config maps, right? So then you can mount that config map to your deployment, and then you're gonna have your resources there. That's exactly what we are doing to our workshop, and then we have a demonstration of that in the repository that Tiago sent. So in this case, we essentially bridge that gap of Terraform outputs with deployment definitions on the Tofu controller because it does that for us. Another way to overcome that challenge could be instead of defining outputs locally, you could use something like parameter store or vault where you persist there and then just get whatever environment variables you have from there. There's many different ways of doing that. And then Crow, the resource sequestrator that it was developed by a bunch of different folks, address the dependency, as Tiago said, because you don't have a really good way to do that on Helm charts. So that's it for the output. I think that's it. And then if you are talking about foundation outputs, either Flux or Argo can look into config maps and secrets to populate manifests. So there's a pattern that Carlos developed called GitOps Bridge for Argo. But essentially, that's it. If you are provisioning clusters from an Argo implementation, that's it. But if you're provisioning infrastructure related resources for your apps, then you can. Tofu Controller already overcomes that challenge. And if you're using Crossplane or ACK, that's even easier because the S3 bucket resource itself will be in your etcd. So you can access whatever output you want from there.
Amazing. Yeah, thank you guys very much. I know we've got some more questions in the chat, but I think we'll have to just leave them wanting more for now. This was really, really, really cool. I really enjoyed this, and I think everybody enjoyed it as well. I think from the questions, it's clear they did. Really awesome, and don't worry, we'll definitely see a lot more of Tiago and Lucas in the community. So we do these webinars every week, and so we will have another one from them certainly on this exact topic. Reminder for some of the stuff we talked about, Tiago shared two links in the chat on workshops. I would heavily recommend looking them up. If you're interested in Crow, which Lucas just mentioned, we actually did a webinar with DevRel for Crow like 6 months ago or something, which was quite good. And Abhinav, yes, you will get the recording of this. We're currently streaming live to YouTube, and tomorrow everyone who registered will get the slides and you'll get the recording emailed to you. So thank you so much for joining, everybody, wherever you are. I hope you have a lovely day, morning, evening, wherever that may be. Lucas, Tiago, thank you again. Bye, everybody.